Hi everyone, welcome to class number 6, and we're continuing with our Villa project. So we've got the normal maps here, and we're going to use a preprocessor for depth, and now we need to create a control net. So it works a little bit differently in ComfUI than it does in InvokeAI. So first we need to load the control net model. So let's type in control net model, load control net model, and because I only have the depth and the normal, these are the two that appear here. If you have more models, they will appear in this list. And then we have to apply the control net to the stream. So apply control net, and here's the node. So the control net gets inserted inside the conditioning stream between the prompts and the K sampler or whatever sampler you're using. Let's just make some more space here. So we want to insert it this way, positive into positive, and then the negative into the negative. Now the actual control net model gets inserted here. The image that we're using, in this case, we're going to use the preprocessor image. So we're going to connect this to the image here. We're going to choose depth, of course. And we need to grab the VAE from the actual checkpoint model. And here we have the familiar controls, the overall strength of the control net, the start percent, and end percent. So let's add another one for the normals. Same procedure. So we can copy this and this time choose normal. Now this will get inserted after the first control net. We just chain them. So again, we're inserting these two into the, into the conditioning stream. Connect the control net, grab the image and the VAE. So let's first check the effect of the depth only without the normals. So we'll zero out the strength of the normals and let's run this. Right, and we got a lot. Straight out of the depth map, we got the whole structure very accurately, even the bushes in front. It even added flowers. That's nice. A lot of the trees, some of them look kind of weird, like a sort of a mix between palm trees and other trees. But there's a lot of detail that we got from this. And just to see, you know, another iteration, let's change our noise value to, let's say, 300 this time and see what we get. Yeah, so a different look, but the detail is still there. The overall composition is exactly the same. There's some weird stuff like the swimming pool. He decided to put it here. This is stuff that we'll need to work on, but let's keep this value of 300 now for this iteration, and let's switch and look at what the normals map gives us. So what you see here, that we're missing a lot of the bigger detail, like the whole, you know, these bushes in the foreground are kind of gone. What we do get from the normals is a lot of fine detail, especially on flat surfaces that are facing us. And it's kind of easy to understand why. If you look at the depth, there's not much detail here on the facades themselves. We get everything that kind of protrudes and sticks out within the depth as very clearly. And that's what it's creating, as opposed to the normal, which clearly gives us a lot of finer detail. So usually a combination of both would work well. So let's try that. Let's set both to 0.5, so they're currently equal. Let's reduce the n% a little bit for the depth. We don't need to go all the way to 1. We want to let the AI model add a little bit of its own detail there. So let's set it to, say, 0.6. And let's set the normals to a bit higher because we're talking about smaller details. So 0.8. And let's see what we're getting now. Yeah, so now we're getting a sort of a fine combination between the bigger details, so the bushes are back, but also the smaller detail within the facades. And these look pretty good overall. Now, as much as we play around with the different weights of the control nets or stack more control nets in, there's a point where what we really need is to control the prompts. Because, for example, I'm not sure I like the pink flowers. I kind of like the idea of flowers here, but maybe they should be white or blue. How do we tell it to change just the color of those white flowers? We don't want the swimming pool here. We want the swimming pool there. So we need to tell the model that we want that. I would maybe want grass here instead of this pavement. So all these fine detail, that's exactly where you want to use masks. And because we are using a render with Cryptomatte, it's much easier than how you would do it otherwise, which is to hand paint the masks. So we can go back to Nuke and output a bunch of masks that we can use here. Here we are back in Nuke, and I've got my EXR here loaded. Let's add a crypto here. And we have the option of using either the material, which in some cases is not going to be helpful for us. For example, if we want to select these bushes, apparently they're using the same material as the trees. So I think object will work better here. So first we want to select the area that where it put the swimming pool wrongly. So let's select this. Let's create another Cryptomatte here. Clear it, and now we want to select the area where we do want to put the swimming pool, which will be this. And each one is giving us a matte, of course. Let's copy this once again. Now we want to select the flowering bushes here, so we should just select each one of them like this. And finally, this area we may want to turn into grass or have some control over it. So let's do this. And you can always come back and output whatever you need. So clear this, select this. Now for each one of those, you want to convert the alpha to color because this is how the mask is going to be created. In Comfy, it's not really using alpha, even though you do have a node that takes the alpha, but it's just easier to use the regular mask from image, and we may as well do it here. So we just add a shuffle to each one of these and just shuffle the alpha into all the color channels like this. Add a right node as usual, render it out as a PNG, and then we can go back to Comfy. Okay, we're again back in Comfy UI, and as you see here, I brought in the 4 masks that we output in Nuke. Now we need 2 nodes that we currently don't have here. One is a node just like this that allows us to put a text prompt, but also has an input for a mask that will define where that prompt affects the image. So we're going to use something from the Inspire pack that's called Regional Conditioning Simple. And it's the same thing. It just gives you an input for a mask. So let's copy the text from here, put it here. We're just going to replace this node with this one. Connect the clip and connect this to the positive here And now we can delete this one. So now we can have multiple nodes like this with different prompts that are constrained by a mask. We can also move the negative down here to make some space. The other node that we need is a node that allows us to combine multiple conditionings before we stream them into the rest of the workflow. And again, there's a few different ways of doing it. We're going to use a KJ node, and it's called conditioning multi-combine. Yeah. And the thing I like about this node is that it allows you to change the number of inputs to whatever you need. So you can change this to 4 inputs, just update inputs. The good thing about this is that a lot of these nodes that have multiple inputs, if you are not plugging something into each one of the inputs, it's going to create an error. Here you can adjust it so you never have this issue. So let's keep it at 2 for now. Now, for some reason, it comes out as brown, but that's not because it's anything special. This is just the node color here. You can change it to gray. And by the way, if you like, you can use the node color to color code your workflow so it's easier to read. All right, so now we want to copy this and create another prompt just for the flowers. So we'll connect it here. We'll take our flower masks. This is an image. We need to convert the image into a mask. So image to mask. Image to mask. Connect it here. And we said we want the flowers to be white. So let's say white flowers. Now we can use the conditioning multi to combine these two together. We have two options here, combine and concat. Concat will put the prompts one after the other as a string, which is not what we want. We want to just combine these two conditioning because they're using a mask. And this will go into the positive. Right. Now we have a mask for this, but we also need a mask for the main prompt. And basically the mask for the main prompt would be the inverse of this. So anything but this area. So we can simply use an invert mask node to get the inverse of this. Invert mask. Connect this to here and the inverted mask to here. And now let's give it a try. So it took us literally and created those giant white flowers here, but this is what we asked, right? And as you notice, everything else remained pretty much the same. We've only affected that area under the mask with the extra prompt. So now we can go and add more masked or regional prompts to kind of control more elements within the image. But before we add more regional prompts, there's one more thing we want to do. If you look at our main prompt, this last part, sunny afternoon photorealistic, really applies to any prompt we're going to put here, right? They're all in the same environment, same time of day, and the same requests to make it or try to make it realistic. So instead of adding this to any of the additional prompts that we're going to add, we can split this kind of similar to what we did in Invoke AI, and then add it as a concatenated prompt after the mix of all the other prompts. So let's just add another regular clip node, because this is not masked. And we, of course, need to connect this to the model. It's getting a little busy here. Let's make some space. So we're going to copy this part, sunny afternoon photorealistic, to here. And we can add another conditioning multi-combine after the first one. And in here, we're going to concatenate. So change this to concat, the second part of the prompt. So this will come right after all the mixed prompts that we have here. And of course, this needs to be connected here. We need to replace that connection. So now this goes into the positive here. So since you kind of got the idea, we don't need to go step by step through the other constrained prompts. I just went ahead and did that, and I can show you pretty quickly what's going on here. So this is our flowers, same as it was. I added another regional conditioning for swimming pool and used the mask for where we want the swimming pool to be, and added a fourth one, grassy lawn, for where it mistakenly put the swimming pool, to fix that. And these are all combined into the multi-combine, which is not now set to 4. And the last thing you want to do is the negative mask that feeds into the main prompt should include all the other masks. So I combine them here with a pixel-wise mask combination node. This is from the Impact Pack. It only does 2, so I had to use it twice to combine all 3. Then these get inverted and plugged into here. And as you can see from the result, the swimming pool is now in the right place, and this has been replaced by a green lawn, and here we still have our beautiful flowers. Now, why do you need to do it this way? Why not just go and do in-painting quickly? Yes, you can do that, but the idea here is that once you set up all this workflow, you can simply go ahead and change the value of the noise and get a different image, but still maintain all these requests: flowers here, swimming pool there, grassy lawn here. So here are some examples of taking the same workflow, same structure, everything we built, and just changing things like the model itself or the CFG or descriptions in the prompt. So here's one example. Here's another one. This is a different model now. Here I changed the main description, the concatenated addition, instead of afternoon, changing it to late afternoon sunset. And here it's a lower CFG, so a slightly different look and feel. And finally changing this all to winter just by changing the prompt. And you see the flowers are still there, just covered in snow. So that's the advantage of using a workflow like this, is that once you set the parameters and you tell ComfyUI where you want everything to be and what you want in all these areas, you can run multiple iterations and have lots of options. Let's talk now about IP adapters. They're not really control nets. An IP adapter is like a visual prompt. So instead of using words to describe what you want, you're using an image. And the model is grabbing all the visual cues from that image and tries to implement them in the generated image. IP adapters are commonly used to as something called style transfer, or also to transfer faces. But you can use them in this context here, especially if you're generating elements for visual effects. You can use them to drastically change the look of the generated image, or match it to a look and a feel of another image or a plate. So as usual, we need to bring those models in and the nodes that we use to load them. So let's go to the manager. Let's go to the model manager and look for IP adapters. And the ones we want to load are the ones that have the SD15 in the name, and we want the regular one, we want the light one, and the plus, which is a stronger version of that model. And now for the nodes, we want the IP adapter pack. So install this and restart. All right, so this is my latest iteration. I'm back to Realistic Vision and CFG2. And I brought in an image I just grabbed from the internet, and you can use whatever you want to test the IP adapter. This is a modern villa. It's a bit more like evening style. It has this nice lighting inside and around. Now, of course, the layout, the composition is not the same as our image, which is fine. In the case of IP adapters, what we really are looking for is colors, lighting, overall mood, not necessarily where things are. Plus minus. So yeah, IP adapters are a bit more tricky to work with because they're not as predictable as using depth or normals, but they are very powerful if you learn how to use them and how to control them. So to create an IP adapter workflow in here, we need to first load the IP adapter model. So load IP adapter and you see that there's two IP adapter model loader and the unified loader. What we want is the unified loader. And if you look in here, you will see the models that you just downloaded. I've got a few more, like a face one. And then we need an IP adapter node. There it is. So let's select here the plus, the high strength version of the model. This connects to the model input here. Now, this all needs to be inserted within the model workflow, so between the checkpoint model and the sampler. Let's move things a bit here. So we can grab the model output from the checkpoint, connect to here, and the output from the IP adapter node goes to the model input in the sampler. Now the IP adapter model itself gets connected here, the image into the image input. Right. And that's it. Let's give it a try. So right away, you can see that without changing anything in the word prompts, we got a very different look. We got all these nice evening lighting inside there, the same sky. It really kind of brought the style of this image and the look of this villa into our villa without changing anything in the layout. That said, we have a big swimming pool here, and it really wanted to bring some of it into our image and add it here. So we can focus the attention through the attention mask here and tell the IP adapter to really look at only certain parts of the image. And we can just draw a mask within the load image node. So right click over it and go to open in mask editor. And now you can simply draw a mask, and I'm basically taking everything except for, the lawn and the swimming pool. Yep, click on save. So now we have this mask, and we can connect the mask straight into the attention mask input here and do another run. All right, so this time we cleared out most of this extra swimming pool. We still have some remnants here. It may be, it may need us to change some things in the masked prompts here, but you get the idea, is we can actually grab from a reference image only those areas that we want to affect the image. Now, we're also using the strongest option of the IP adapter. We can try, for example, to go to the medium strength standard one And let's see what we get now. All right, so you see that we preserved a lot more of the original image, the same older sky of the afternoon sky, a closer look to what we had, but we did get all these lights and interior lights as we have in the reference image. So as you can see, there are quite a few different options to control the IP adapter. You can switch between the different models. You can change the overall weight. You can change the end percent and the start percent, and you even have a few more options here. So to summarize these last two classes, we created an entire image, but the idea here is that you can create specific elements for matte paintings, for compositing, for integrating within a shot. And the power of using control nets like depth and normals allows you to control exactly where the camera is so that you can match to the play, you can match the perspective, the scale, and force the generation to be very, very specific to your needs. And using IP adapters, you can affect the overall feel and lighting and color of the elements that you're creating to match a plate or another shot. So I hope this has been helpful to give you some ideas on how you can use Comfy UI for creating elements for visual effects.